Logarithmic equations 2. In this video, we're going to talk about solving equations involving logarithm. That is, solving some kinds of simultaneous equations involving log. How do we get this kind of question solved? We have 2 log x base 2 plus 2 log y base 2 equal to 8, termed as equation 1. And then we have log x base 2 minus log y base 2 equal to 1, termed as equation 2. Once again, I refer you to some of the videos I made on my channel on theory of logarithm, because it is actually pertinent to understand some concepts of laws of logarithm, changing the base of logarithm to get some questions done on log equations. So remember, when you're solving an equation, the purpose is to get the values of the unknown. In this case, we have 2 values that are not known. We have x and we've got y that are not known. But how do we solve for the values of x and y in this set of simultaneous equations? So this is what we do here. Of course, we can just represent log x base 2 to be a kind of some other letters. Let's say we let log x base 2 to be p, and then maybe log y base 2 to be q. And then that tells us that wherever we see log x base 2, p can be substituted. And wherever we see log y base 2 in the equation, q can be substituted. So we're going to have, in this case now, we're going to have 2p. So the first equation there is going to give us 2p plus q equal to 8. That's the first equation. Then the second equation is going to be p minus q equal to 1. This is the first equation, and then this is the second equation. So this has made it becomes a kind of pretty easier simultaneous equation to be solved. And in this case, we can make use of any method solving simultaneous equation here, but I prefer to use elimination method. Remember, we have some kinds of method to solving simultaneous equation, like substitution method, graphical method, elimination method, even matrix method can be used to solve simultaneous equation. But let's go ahead and use substitution method, elimination method in solving these simultaneous equations here. So we check out the q and the q variable here. They have the same coefficient, so we can just go ahead and add up the 2 equations in the sense that they have different signs. Remember, if they have different signs, that can be added up. So we have 3p here, that is 2p plus p, and plus 1 minus 1, that's going to be 0, equal to 8 plus 1, that's going to be 9. And then solving for p actually becomes very easy. Dividing both sides by 3, and our p becomes 3. And then we've got to substitute 3 for the value of p in any one of the equations. So we go ahead substituting 3 for p in, let's say, equation 2, and that becomes p minus q equal to 1. That's equation 2. And then p is 3 minus q equal to 1, and then we have minus q equal to 1 minus 3. That's when you move 3 to the other side of equality sign, and then minus q becomes minus 2. This get rid of this, so our q is going to be 2. If q is equal to 2, so our p equal to 3 and q is equal to 2. But recall that we have not actually solved what they ask us to solve for in the equation, in the sense that there is no term labeled as p or q in the equation. What we have in the 2 set of the log equations is x and y. So how do we now get values for x and y? We've got to recall here. We recall that log x base 2 equal to p. That's what we said. Now that p is equal to 3, that can actually be log x base 2 equal to 3. And then if log x base 2 equal to 3, then we can actually get this solved by changing that to an index form. Okay, this is going to be 2 to the power of 3 equal to x. That's how a log form of equation can be changed to an index form. So our x a equal to 2 raised to the power of 3, and our x is going to be 8. At the same time, we can actually recall that our log y base 2 equal to q, and therefore in as much as the value of q is equal to 2, and then we need to proceed to write log y base 2 equal to 2, and then changing this to an index form, that becomes 2 raised to the power of 2 equal to y, and our y 2 raised to the power of 2 is 4, and therefore our x equal to 8 and our y equal to 4. So that is how to obtain the values for x and y in that log form of simultaneous equations. Let's take a look at another example here. Here is we have log x base 2 plus log y base 2 equal to 5, and then here is log x base 4 minus log y base 4 equal to minus 0.5. We've got to be very careful in solving this question, in the sense that all the terms of the logarithm you have there have different base. For example, in equation 1, you have log to base 2, and in equation 2, we have log to base 4. So we've got to convert or change the base of one log to the other. Okay, once again, I've done or made videos on changing base of logarithm. So I refer that we can actually go get some pertinent understanding on how to change the base of logarithm. In this case, we need to change the base. Either we're changing the log x base 2 to base 4 or log x base 4 to base 2. But I prefer we use the smaller base in this case. But any one of it will simply work. And therefore, let's first of all deal with this question by changing all the base 4 we have to base 2. And how do we do that? Okay, let me write this as solution here. Okay, we want to change this one from equation 2. This is equation 1, and this is equation 2. We want to change this one to base 2. And then remember, if I change the log x base 4 to base 2, that's going to be the log of the number to base 2 itself divided by the log of the base and then to base 2 minus the same thing with log y here. This one is going to be log y, okay, to base 2 divided by log 4 to base 2 is actually equal to negative 0.5. And then this can as well be expressed as log x base 2 divided by log 2 square base 2 minus log y base 2 divided by log 2 square base 2 equal to negative 0.5. And then we need to use one of the laws of logarithm to express this as log x base 2 divided by this 2 is becoming a coefficient log 2 base 2 minus log y base 2 divided by the same thing here. 2 is becoming a coefficient there, log 2 base 2 equal to negative 0.5. And then remember, log 2 to itself base 2 is going to give us 1. And therefore, basically what we have there is 1 over 2 has the coefficient. So that's 1 over 2 log x minus the same 1 over 2, that's 1 over 2 log y equal to, we can change this one to a negative minus 1 over 2, that's 0.5 there. And when we got to this level, we can actually, that is to base 2 to base 2. Now we can represent log x base 2 with a different alphabet so that we can actually find it more convenient to solve for x and y. So we can say, this is log x base 2 be p, and then log x base 2, log y. This one is log y base 2 be q. So we're going to substitute p for log x base 2, and we substitute q for log y base 2. And then doing that takes us down to combining the two equations in the form of p and q. So if we're going to do that, okay, we're going to have p plus q equal to 5. That is the equation 1, which says log x base 2, which is p, plus log y base 2, which is q, equal to y. And then now that we've sorted out this one to be half log x base 2 minus half log y base 2 equal to 1 minus 1 over 2. So we're going to represent that with respect to p and q as well. And that's going to be 1 over 2p minus 1 over 2q equal to minus 1 over 2. So this is what we've actually got to solve simultaneously. And then solving this simultaneously, this is going to be equation 1 and equation 2. Solving this simultaneously, and of course, this and this or this and this does not have the same coefficient. So we've got to actually multiply through by the coefficient here, the coefficient of one of these variables so that we can actually eliminate any one of them. So multiplying this by 1 over 2, that's coefficient of q, and I'm interested in getting rid of q there. The coefficient of q is 1, so we'll multiply this one by 1. So multiplying all of this gives us 1 over 2p plus 1 over 2q equal to 5 over 2. That's 1 over 2 times 5. 1 times everything that remains the same. 1 over p minus 1 over 2q equal to minus 1 over 2. So we can go ahead and eliminate the term q there. Minus 1 over 2 plus minus 1 over 2q, that is going to be 0. When you add 1 over 2 plus 1 over 2p, that's going to be 1. And then this one is giving us p equal to 5 over 2 plus minus 1 over 2. If you do your calculation there, you're going to get 4. And then, 4 over 2, which is going to be 2. And therefore, this one is going to be 5 over 2 plus minus 1 over 2. Here is p equal to 5 over 2 minus 1 over 2. And then our p, the LCM is going to be 2, and of course 5 minus 1. And then our p is going to be 4 over 2. And our p is going to be 2. And then we can go back and substitute now. We substitute 2 for p in any one of the equation. I think equation 1 will be pretty easier for us to handle there. That's p plus q equal to 5. That's equation 1. Now that p is equal to 2, so we're having 2 plus q equal to 5. And of course, q is going to be 5 minus 2. And of course, q is going to be 3. Now that we have p to be 2 and q to be 3, of course, we need to solve now for the value of x and y. So we've got to recall, okay? We actually recall that our log x base 2 equal to p. In this case, that means our log x base 2 is equal to 2 because p is equal to 2. Changing this to an index form, that becomes x equal to 2 raised to the power of 2. That's going to be 4. That's 2 squared. Therefore, our x equal to 4. In the same vein, recalling log y base 2 to be equal to q. Now that our log y base 2 equal to 3, and then changing this to index form, that becomes y equal to 2 raised to the power of 3, and our y is meant to be 8. Therefore, our x equal to 4 and our y equal to 8. So that is how the values for x and y can be obtained in such log equations. Thanks for watching. Kindly subscribe to my YouTube channels.